Somewhere in your basement right now, water is winning. Maybe it's a slow seep along the base of the wall. Maybe it's that musty smell that never quite goes away no matter how many times you clean. Maybe you've already spent thousands of dollars on sump pumps and French drains and waterproofing companies that promised you the world and delivered a damp check and a business card. And here's the part that nobody tells you. The part that will genuinely make you stop and sit down for a second. There is a mineral that costs about $2. $2. You can buy it at a garden center, a pool supply store, or online with next-day shipping. It's been sitting on shelves for decades. Farmers use it, pool owners use it, health food enthusiasts put it in their smoothies. And almost nobody has figured out that it might be one of the most effective, affordable, and completely overlooked solutions to one of the most expensive problems a homeowner can face. That mineral is diatomite. And before you click away, before you write this off as some kind of folk remedy or internet myth, stay with us for just a moment. Because what we're going to walk you through in this video is not a trick. It's not a sales pitch. It's the actual science behind why this ancient, naturally occurring material interacts with moisture in a way that has researchers and builders quietly taking notice. We're going to show you exactly what diatomite is, where it comes from, and why its microscopic structure does something that multi-thousand-dollar waterproofing systems struggle to replicate. We're going to show you how to apply it, and we're going to show you what homeowners who have already tried it are saying happened next. Because sometimes the most powerful solutions aren't the expensive ones. Sometimes they're the ones that have been hiding in plain sight all along, waiting for someone to just ask the right question. So, are you tired of a wet basement? Good. Let's talk about $2. Let's start with the problem itself. Because if you've ever owned a home with a basement, there's a very good chance you already know exactly what we're talking about. That smell. That particular damp, heavy, slightly sour smell that hits you the moment you open the basement door. Maybe you've got water stains creeping up the lower half of your walls like a slow tide that never fully goes back out. Maybe you've got puddles after a heavy rain. Maybe it's not even visible water. Maybe it's just that the air down there feels thick and everything you store in that space comes back upstairs, smelling like it's been sitting at the bottom of a lake. This is one of the most common problems in residential housing in America. Estimates suggest that somewhere between 30 and 60% of homes in the United States have some form of basement moisture issue. That's not a fringe problem. That's tens of millions of households dealing with this exact situation right now. And here's the thing that makes it so frustrating. It's not just an inconvenience. It's not just a smell. Persistent basement moisture is the starting point for a cascade of damage that can quietly cost you enormous amounts of money over time. Mold and mildew take hold fast in those conditions. And once mold gets into your walls, into your framing, into your insulation, remediation costs can run into the thousands almost immediately. We're talking $5,000 on the low end, easily $10,000, $15,000, $20,000 if the problem has been sitting untreated for years. Then there's the structural element, water that repeatedly contacts your foundation walls, whether that's poured concrete, block, or stone, is doing something you can't see. It's working its way into the tiny pores and cracks in that material. And every time temperatures fluctuate, every time that moisture freezes and thaws, those cracks get a little wider, a little longer. Foundations don't fail overnight. They fail over years of exactly this kind of slow, repeated moisture exposure. And beyond the physical damage, there's the health dimension. Basements that stay damp become breeding grounds for allergens, for respiratory irritants. Families with young children, with elderly relatives, with anyone who already deals with asthma or allergies, are living above an air quality problem they may not even be connecting to their symptoms. Homeowners know all of this. That's why the waterproofing industry is worth billions of dollars a year. That's why companies can charge $8,000, $12,000, even $20,000 to come in, tear out sections of your basement floor, install drainage systems, apply epoxy coatings, and set you up with a sump pump that may or may not work well enough to justify what you paid for it. And yet the problem persists. For a lot of people, even after spending that kind of money, the moisture finds a way back. Which raises a question worth asking. What if the solution isn't about moving water out? What if it's about stopping it at the surface in the first place? So let's talk about what diatomite actually is. Because there's a good chance you've never heard the word before, or if you have, you've heard it in a completely different context. And that's part of what makes this story interesting. Diatomite, sometimes called diatomaceous earth, is a naturally occurring sedimentary rock. It forms over millions of years from the accumulated remains of diatoms, which are microscopic single-celled organisms that live in water. oceans, lakes, rivers. Diatoms are everywhere there's water, and they have been for a very, very long time. In fact, diatom fossils date back roughly 240 million years. These organisms have been living and dying and settling to the bottom of ancient water bodies since long before the first dinosaur ever walked the earth. When diatoms die, their soft organic material breaks down, but their outer shells, made of a substance called silica, those don't break down. They accumulate, layer after layer, century after century, compressed over geological time into dense deposits of soft, chalky, sedimentary rock. That rock is diatomite, and here's where it gets interesting. When you crush diatomite down and examine it at the microscopic level, what you're looking at is not a solid material, it's full of holes. The fossilized shells of those ancient diatoms are intricate, geometric, almost architectural in structure. They're riddled with tiny pores, channels, chambers. The surface area of diatomite is enormous relative to its volume. 1 gram of the stuff can have a surface area equivalent to several square meters. That's not an exaggeration. That is the actual physical reality of what this material is. Now, because of that structure, diatomite has some remarkable properties. It's extremely lightweight. It's highly absorbent. It can soak up to 1.5 times its own weight in liquid. It's chemically stable, meaning it doesn't react with most substances and doesn't break down easily. And it's naturally porous in a way that synthetic materials simply cannot replicate at the same scale or cost. For most of the 20th century, industrial applications claimed diatomite almost entirely. It became a filtration medium. Breweries use it to clarify beer. Water treatment plants use it to filter drinking water. The pharmaceutical industry uses it to purify products. You've probably consumed something today that was filtered through diatomite at some point in its production process, and you'd have no way of knowing. It's also used as a mild abrasive in some toothpastes, as a thickening agent in paints, and, this one surprises people, as a pesticide. Because at the microscopic level, those sharp silica edges are harmless to humans, but lethal to insects. Gardeners and farmers have used food-grade diatomaceous earth for decades to protect crops without chemical pesticides. But all of those applications, every single one of them, was built on exploiting just 1 or 2 of diatomite's properties at a time. Nobody was looking at what happens when you apply it to a porous concrete wall. Nobody was thinking about moisture control. Nobody was connecting those extraordinary absorption and surface area characteristics to the specific, stubborn, expensive problems sitting in millions of basements across the country. Until, eventually, someone did. So let's talk about what's actually happening at the molecular level. Because this is where it gets genuinely interesting, and honestly, this is the part that makes you wonder why it took so long for anyone to figure this out. Concrete feels solid. It looks solid. You knock on a basement wall and it sounds solid. But concrete is, by its very nature, full of tiny passages. When it cures, water evaporates out of the mixture and leaves behind microscopic channels called capillaries. Those capillaries don't disappear. They stay there permanently, running through the material like an invisible network of straws, and water, given any opportunity at all, will find those straws and use them. That's not a flaw in your specific basement. That's just what concrete is. The technical term for this process is capillary action. It's the same force that pulls water up through the roots of a tree, the same force that makes a paper towel soak up a spill. Water molecules are attracted to the walls of narrow passages, and they climb. They don't need pressure to do it. They don't need a crack or a gap or a visible point of entry. They just move, steadily and persistently, through passages you cannot see with the naked eye. Now here's where diatomite enters the picture. When you apply diatomite to a concrete surface, you're not just coating it. You're introducing a material with a surface area so enormous it's almost difficult to comprehend. Remember those microscopic pores, those tiny chambers and channels running through every fossilized shell. A single gram of diatomite can have a surface area of several square meters. Let that settle for a moment. 1 gram. Several square meters of surface area. That's not a coating. That's a labyrinth. When water vapor or liquid water attempts to migrate through a treated wall, it encounters that labyrinth. The water molecules are absorbed into the diatomite structure. They get pulled into those microscopic chambers and held there. The silica matrix is hydrophilic. It attracts water, but it's also structurally stable, meaning it doesn't swell or degrade when it absorbs moisture. It simply holds it. And then, when conditions on the other side of the wall dry out slightly, when humidity drops or airflow increases, the water releases back as vapor outward away from your living space. What you're creating, in effect, is a buffer. A dynamic, responsive buffer that absorbs moisture before it can migrate further and releases it when the environment allows. It's not a barrier in the traditional sense. It doesn't seal the wall like a sheet of plastic. It manages the water. It interrupts the capillary action by giving the moisture somewhere else to go, somewhere better to go, before it reaches the interior surface. There's also a secondary mechanism worth understanding. Diatomite is naturally alkaline. Concrete, over time, can become more acidic as it reacts with moisture and carbon dioxide in the air. That acidic environment actually accelerates the breakdown of the concrete itself, widening those capillaries and making the moisture problem progressively worse over time. The alkalinity of diatomite slows that process down. So you're not just managing the symptom, you're addressing one of the root causes of why basement walls deteriorate in the first place. Two things happening simultaneously: moisture capture and structural preservation, and the material doing both of those things costs about as much as a cup of coffee. So now you understand why it works. The question is how to actually do it. And this is where things get surprisingly simple. You're going to need diatomite powder, a bucket, water, and something to apply it with. That's essentially the whole list. Some people use a wide paintbrush, some use a masonry brush with stiffer bristles. Either works. If you have a large area to cover, a basic garden sprayer will save you a lot of time and your arm a lot of effort. Start with your walls dry, not bone dry necessarily, and we're talking about a basement, so some ambient moisture is expected. But you don't want water visibly running down the surface or pooling at the base. If that's happening, give it a day or two after a rain event before you begin. You want the diatomite to bond to the surface, not float off it. Clean the wall first. This step gets skipped, and it absolutely shouldn't be. Efflorescence, that white chalky residue you see on older basement walls, needs to come off. It's a salt deposit left behind by evaporating water, and it'll interfere with adhesion. A stiff wire brush handles most of it. For heavier buildup, a mild acid wash with diluted white vinegar works without introducing harsh chemicals into your space. Rinse it, let it dry down to that baseline moisture level, and then you're ready. Mix your diatomite with water. The consistency you're aiming for is somewhere between a thick paint and a loose yogurt. Not so thin it runs off the wall immediately, not so thick it clumps, and won't spread evenly. A rough starting ratio is about 2 parts diatomite powder to 3 parts water, but you'll adjust based on what you're seeing in front of you. Mix it thoroughly. There shouldn't be dry pockets sitting at the bottom of the bucket. Apply your first coat. Work from the top of the wall downward in long, even strokes. You want coverage, not thickness. A thin, consistent layer is more effective than a heavy, uneven one. Pay attention to corners and the joint where the wall meets the floor. That seam is one of the most common entry points for moisture, and it needs full coverage. Don't rush past it. Let that first coat dry. Depending on your basement's humidity and airflow, that could take anywhere from 4 to 8 hours. You're looking for the surface to go from dark and wet-looking to a lighter, matte finish. Once it's there, apply your second coat. Same technique, same direction. 2 coats is the standard recommendation for most basement walls. If your walls have visible cracks, significant staining, or you know the hydrostatic pressure on the exterior is high, a third coat isn't overkill. For active cracks where you've actually seen water seeping through, mix your diatomite slightly thicker for that first pass and work it directly into the crack with a putty knife or even just your finger before applying the broader coat over the top. You're not filling the crack structurally. You're giving the moisture a managed path rather than a free one. Once everything is cured, give it a full 24 hours minimum before you start bringing furniture back or stacking anything against the walls. You're done. No ventilation requirements during application. No special disposal. No waiting for a contractor's schedule to open up. The total material cost for an average basement, somewhere around 800 to 1,000 square feet of wall surface, runs between $40 and $80. For smaller spaces, or if you're just treating a problem wall, you can easily come in under $20. That's the whole process. An afternoon of work, a bucket of mineral powder, and a wall that is now actively managing moisture instead of slowly losing the fight against it. Now all of that sounds good on paper, but the real question is whether it actually works when someone stops watching a video and starts using it in their actual house with their actual problem. So let's talk about that. Take a homeowner in the Midwest, older ranch house built in the early 60s, unfinished basement that had been collecting water along the north wall every single spring for as long as the current owners could remember. They'd tried the paint-on rubber coatings twice. The second time, they'd even paid a professional to do it. Within 18 months, both times, the coating had bubbled away from the wall and the damp was back. Worse, if anything, because now there was trapped moisture behind a sealed surface with nowhere to go. They applied 2 coats of diatomite slurry in March. The following spring, nothing. Not a wet patch, not a white mineral stain on the floor, not the smell. They described it as the first dry spring the basement had ever had in their ownership. Or consider a finished basement situation, which is honestly where the anxiety gets expensive. A homeowner in the Northeast had converted their basement into a home office. Nice floors, drywall, the whole thing. They started noticing soft spots near the base of one wall, that telltale sign that moisture had been moving through the concrete and into the framing long before anyone noticed. They pulled the drywall back about 2 feet from the floor along that wall, treated the exposed block with diatomite, let it cure, and re-drywalled. That was 3 years ago. The soft spots never returned. They didn't have to excavate the exterior. They didn't have to install a drain tile system. 2 feet of exposed wall and an afternoon. And it's not just residential. A small business owner using a converted brick building for storage had chronic condensation issues. Stock was getting damaged, insurance questions were being raised. The interior brick walls were treated with diatomite, and within 2 seasons, the condensation problem had reduced dramatically enough that the space became usable for anything they wanted to store there. These aren't outlier stories. The pattern that comes up again and again is the same. People who had spent years fighting moisture with sealants that create a hard barrier find that the moment they switch to something that works with vapor movement rather than against it, the problem stops feeling like a battle and starts feeling like it's just been quietly solved. Now, none of this means diatomite is a miracle that works identically in every situation. If you have a foundation crack that's moving, a structural crack, that's a different conversation entirely, and this isn't a substitute for that kind of repair. But for the vast majority of damp basement complaints, which are vapor transmission, minor seepage, and chronic humidity, the results people are seeing with this material are genuinely difficult to argue with, especially at that price point. So let's put it in context. Because if you've spent any time looking into basement waterproofing before today, you've probably encountered the other options. Interior drain tile systems that require jackhammering your floor. Exterior excavation that means digging down to your foundation footings. Crystalline waterproofing compounds. Epoxy injections, French drains. Sump pit installations. These aren't small investments. A professionally installed interior drainage system can run anywhere from $5,000 to $15,000 depending on the size of your basement. Exterior waterproofing with full excavation can push past $20,000 without much effort. And here's the thing that makes the comparison uncomfortable for the industry. Many of those systems are solving the symptom rather than the underlying dynamic. They're redirecting water, or they're sealing a surface so hard that moisture finds another path. Diatomite works on a different principle entirely, and it costs roughly $2 a pound. It doesn't require professional installation. It doesn't require permits. It doesn't require you to empty your savings account and wait 3 weeks for a crew to show up. For the specific problem of vapor transmission and chronic ambient moisture, which, again, is the majority of what people are actually dealing with, the cost-to-result ratio here isn't just favorable, it's almost unreasonably so. So here's where we land. You now know what diatomite is, where it comes from, why it works, and exactly how to use it. You know it costs $2. You know it's been sitting in garden supply stores and pool supply aisles for decades, completely overlooked by anyone trying to solve the exact problem it was built to solve. The next step is genuinely simple. Pick up a bag. Start with one wall. Apply it the way we walk through, give it time to work, and then go back down and see what you're looking at. You don't need a contractor. You don't need a permit. You don't need to commit to a 5-figure decision before you've seen a single result. You need an afternoon and a few dollars, and you can have your answer. Millions of homeowners are losing sleep over wet basements right now, writing checks to solve a problem that might be sitting on a hardware store shelf at $2 a pound. Don't be one of them anymore.